Hi all, my name is Jayasri, working as Assistant Professor in Department of CSE AIML in MLR IT. Today, in this session, I would like to discuss about presentation and visualization services in cognitive computing. What is presentation? Presentation talks about how cognitive system deliver insights or results to the user. Now, presentation is nothing but whatever context you have, the context, how well you are delivering it to the other person. It generally, the presentation itself all over the world, it only tells about how well you talk about the concept you have and how well is the person able to receive the whatever context you are discussing. The same way in cognitive computing also, the presentation tells about how you are delivering the insight or how the user is able to understand and get the result out of your presentation. First thing, how your cognitive system is delivering the insight or the result of the user. This is the presentation, what we tell and what did you understand? What you delivered? What is the result? Right? Visualization. Next, talking about visualization, as our topic itself tells about presentation and visualization. So, visualization tells that the context what you are trying to explain to the opposite person may be in a normal text format. It can be just an oral form or it can be a graphical representation form. But mostly the people understand or people remember only the context which is shown in graphical representation. Many 70 to 80% of people understand the graphical representation. That is the only reason where we don't remember our textbook topics and we remember the movie. Graphical movie. That is the only reason. Right. So, here talking about visualization is it shows the graphical representation of data. Whatever data I am trying to explain or I am trying to deliver, I am showing that data in the form of graphical representation. By this, I analyze for a better. Why am I doing this? To analyze the context properly and understand it in a better format. How relevant is it? Talking about the relevancy of presentation and visualization is it makes the complex data and AI driven insights easier to comprehend. That is, it makes what if the data is complex or if the data AI driven data or insights is very complex. Now, these kind of complex data can be easily comprehended and delivered to the user. That is the first relevance. Second relevance is it enhances user interaction and decision making. It will be easy for user interacting and also it is easy for decision making. You may ask how decision making comes into relevance. In case if you are able to understand the concept very easily, you will decide whether to go and watch the movie again or you don't need to watch it again. So you understand it better and you deliver the same content to the other friend or other person or your neighbor, your family relative easily that chalo, you can watch this movie again. So in this, it helps in decision making. You understand the topic properly and it enhances also the interaction to the user very aptly. It interacts in a apt manner. Now, let us talk about the components of visualization. What are the components here? There are probably 5 components here. One is data preparation. Data preparation. Your data is used to organize for clear and effective presentation. Your data is organized in a proper format in such a way that it is clearly presented and it is clearly and effectively presented. Example, you are cleaning the data, you are aggregating the data, and you are selecting the relevant data, what all data you need to pipeline, and you have to arrange it in a proper manner. So here the data preparation talks about organizing the data clearly and effectively for a better presentation, and the process is cleaning the data and it aggregating the data. Along with it, you are selecting a proper data which is having a proper pipeline to have the continuity without any irrelevance of the content. Next is graphical representation. How do you represent graphically? How do you show the data in a graphical format? Using charts, graphs, infographics like line graphics for trends, heat maps. These are heat maps for distribution, network diagrams for showing the relationships. For all this, we are using a graphical representation. Next is interactive dashboards. We need to have some interactive dashboards so that if any data is popped up, you will filter whether it is required or not required. So you are talking about the user interfaces for exploring the insights. Your user interfaces are used for exploring the insights like filters, drill down features, real-time updates, and so on. Now you have, we are taking the example of a website, and in that website you will have multiple informations which are related, not related. You will have ads around, popping up, scrolling down, and some will be scrolling on the header, some at the bottom. So those data is not required for you. So you can roll out the features, and you can drill down them, stating that these are not required. Whatever data is required content, you will only drag and go through the content. So your user interfaces will help in exploring the insights in an interactive way. Next is storytelling. If you have to tell this a story to small children, your presentation goes like combining narrative with visual. You narrate the story and you show it visually, which can be conveyed in an effective manner. You can convey the insight more effectively if you are narrating the story as well as visualizing it. You are showing the visual to them on the television or smart board, whichever is there. And along with that, if you are narrating and explaining to a student, it will be more effective and in an understandable way. Example, you're timelining an event to explain patterns in healthcare data. That is, I'll only spend so much time for completing a storytelling. You will just complete it in 20 minutes and you are done. So you are timelining the event and you are using the pattern format to explain the data. It can be in any application. Here I just took an example of healthcare. Now coming next is the comparison between static and dynamic visualization techniques. Talking about static and dynamic visualization techniques, if we consider a static visualization is like you are pre-designing it, which is not having an interactive session. Visual representation of data undadu, non-interactive visual. You don't interact prior. Non-interactive visual representation of data. Without interacting, you just show a visual representation of data is static visualization. Whereas dynamic talks about it is interactive. Along with that, it shows a real-time visual representation which allows the user engaged. Your user will not be bored if he is not he will be bored if he is not engaged. But which happens in static. But in dynamic, your user will be engaged when you are showing a real-time visual representation because you are having some interaction. So here you are interacting. Dynamic visualization, you are interacting and making user engaged. But static tells you have no interaction, but you are just showing a visual representation of data. How interactive is it? No interaction. User can only view the information, whereas dynamic visualization is highly interactive. User can explore data through filters or zooming, etc. Next is data updates. In static, it requires manual updates, static after creation. But in dynamic, it is automatically updated in real time when data changes. Data updates, static no, manual you have to do it. Manually data should be updated, but in dynamic, your data is updated automatically. What are the use cases? It reports, it shows infographics, it gives you a printed charts in static. But in dynamic, you have dashboards, you have real-time monitoring, you have live analytics. That is, in live analytics shows, you say A, it tells A doesn't make a sentence. A is an alphabet. Make a sentence. That is live analytics. It will analyze what you are telling and it interacts with the person what to do. That is use cases. Tools or technologies talks about static like Excel, Matplotlib, PowerPoint, and in dynamic it's about Tableau, Power BI, D3.js, Plotly, and coming to the complexity, it is easier to create and understand. This is a bit complex and it requires technical expertise to build. The advantages, coming to advantages, it is simple to produce and share. It is best for static database. It is simple to produce. It provides deeper insights through interactive. And in real time, decision support is given. If you check the complexity, now it is not easier for a director of Avatar or any animated movie it is not easy for a normal director to direct a movie like Avatar or any animated movies which are done Hollywood theme. So the creativity only depends on how technical the director is. It shows the expertise in that particular subject. Likewise, it is showing the complexity. If you are able to crack the complexity, then you are good with the data, you are good with the skill. If you are not able to crack, or if you are not able to crack the complexity, then you are not on the run, you are just there with the data. That is what your complexity talks about. Okay, what are the disadvantages? Advantages talks about it is simple to produce and share. It is simple. You can be in your own comfort zone. You can just static visualization, whatever is there, you can present in a normal format. It is easy. It is simple to do. It is best for static data set. But when you're talking about dynamic, it provides deeper insight, and also it should be interactive, and it should have a real-time decision support, so that your system should also find it makes decision whether it has to go forward or no. For this, it should have a real-time support. That is a more advantage, basic and more advanced advantage. Talking about disadvantages, we have limited insight for dynamic data sets and it cannot be accommodated. The real-time changes cannot be accommodated. In dynamic, we can overwhelm for non-technical users. Along with it requires computational resources. Now, if you see the visual comparison, whatever I told here in this chart is visually shown here. What is static visualization and what is dynamic visualization? Here is a comparison chart which talks about, and here we have the highlights key aspects like how interactive it is, what are the use cases, what are the tools and educational processes and so on. So here in static visualization you can see that we have charts, we have bar charts, and we have use cases. Along with that, the representation of percentages, how what is the percentage shown regarding the people, or what is the average taken over for any particular information of a particular zone, is shown in this static data. But in this dynamic data, this is a bit advanced, wherein it is showing the graphical representation with key points, where is it and why is it the data going up, going down. Based on the data, it represents or it shows the chart. Along with that, it also supports the use cases, or what are the use cases used in case if you use other use case, or if you use another algorithm, why is it showing in this format. It clearly gives the explanation of it. That is dynamic visualization. Talking about the examples of static and dynamic, your static visualization is mostly represented in bar charts and line graphs. Bar charts, how is it represented? Using annual revenue comparison across multiple years. Static visualization, it is showing a bar chart using that actually it can be used using any data, but that's an example considered here. Annual revenue comparison, say I have a company XYZ where I need to show the annual revenue by comparing, say 2024 is giving me some 60% revenue, which is turnover of the annual income, and I am comparing with other years and I am plotting a graph, right? That is static visualization. Dynamic visualization, sorry, I missed here, line graph. Historical temperature trends over decades. Line graph shows that the historical temperature trends over decades from say 14th century to 2000 century, right? So here it shows that the decades, line graph, and it shows that from so many decades the data is retrieved, and it is showing the presentation in the form of line graph, right? So this is clear, the data is clear and presentation is clear, and it's simple. Talking about dynamic visualization, here there are two. One is interactive dashboard and live map. Interactive dashboard talks about sales, which trends filtered by region and time. I have some sales of a product A. AB is a product, BC is a product, right? I have some sales, and based on the trend, I am filtering by what region, say Telangana and AP. Okay, Telangana and AP. What is the sale for 2025? Right, so here sale trend filters the region and time, and it gives a clear representation that what is the range of the particular AB and what is the sale rate of BC in this area and this area. This is comparison a bit better than static. Next is live map. This talks about real-time traffic conditions or weather updates. Real-time traffic conditions is something that it is tracking every second for all 365 days for the whole year, and it is giving you the real-time data This is one, and the other is it is giving the update of the weather, whether it is going to rain today, tomorrow, and whether it is sunny, it is windy, you have a storm, you have thunders, and so on. It keeps on updating the weather, and here it keeps on updating the real-time traffic conditions. So your dynamic visualization is more effective and more interactive. It is more interesting compared to static. Likewise, it is very complex, and it is very understanding the algorithm or understanding the in and out of it is a bit difficult in visualization. But when you are seeing it in a visual format, dynamic visualization is much more better than static. Here, static visualization is pre-designed, having a pre-designed charts and reports like financial summaries, business forecasts, so on. Dynamic visualization here is talking about real-time updates and interactions. Example, traffic monitoring dashboards, as we have discussed in the previous slide. There is another visualization called predictive visualization. What is predictive? Which shows the prediction and trends. Predictive is something that which shows the prediction and trends, like predictive maintenance of charts in IoT. And prescriptive visualization is something that which offer actionable insights or solutions. It offers actionable insights and it offers actionable solutions, like recommendations in e-commerce system. I have a shopping website. I have some products shown here. I select and put it in my cart. I select few items and add to my cart. This will lead to my cart, and this leads to payment board. Okay, so my e-commerce website will give some offer which is actionable insight or solution, that it will say it is giving me 50% off. So I go to e-commerce website, I shop few products, put it in my cart and buy it. This is prescriptive visualization, that you are visualizing it, you are finding the action insights and you are finding a solution for it. You are just going for the interested product. Yes, next going on to tools and technologies. What are the tools used in visualization is Tableau, Power BI, Matplotlib and D3. Examples, coming to examples, we use Power BI for business intelligence dashboard, and the next is AI specific tools like IBM Watson Analytics, TensorBoard. This is an AI model. Now, example for AI specific tool is IBM Watson Visual Data Stories for business insights. The other tool is AR/VR, where your AR/VR talks about immersive analytics for better interaction, like AR based city planning tools for urban development. The next is AR/VR in visualization. The other tool talks about AR/VR. AR/VR is nothing but augmented reality and virtual reality. Augmented reality, mostly AR/VR in visualization. VR. AR talks about the real world. VR speaks about the virtual reality. And here it is immersely acting as an analytics for better interaction. Here examples are AR, which are based on city planning tools for urban development. City planning tools for urban development. Applications, again, it's about healthcare, finance, education, transportation. Healthcare is visualizing patients' record, treatment outcomes. We have discussed in the previous video about the applications. The same applications are applied for visualization also. So here in healthcare, you are visualizing patient's record, and along with that you are also showing or visualizing the treatment outcomes. Example, interactive dashboards for hospital management. You are having an interactive dashboards. And next application is finance. Finance talks about risk analytics and fraud detection using heat map and trends. Okay, education is used for personalized learning analytics for student progress. Transportation, monitoring vehicle movements and traffic patterns. These way of applications we've already discussed, so I'm not going into deep. Yes, talking about the benefits of visualization is it enhances understanding of data. This basically gives the enhancement, and it supports better decision making. It will support for better decision making, and it makes complex data accessible to non-technical users. It makes the complex data accessible also for non-technical users, not only technical users. Okay, these are the three major benefits. What are the challenges here? It requires clean, well-structured data, as we have seen in the previous video. The same challenges are followed for visualization also. The second challenge is it is high computational requirements for dynamic visualization. The next challenge is risk of misinterpretation due to oversimplified visuals. Risk of misinterpretations. Because here the third point talks, the visual is shown something else and your understanding may be something else. So that risk of misinterpretation, misunderstanding of the visual is reduced and it is clearly, the data is clearly shown for better understanding. Now summarizing the topics here before closing the session, that is visualizing bridges. We are visualizing the data to bridge the gap between data and actionable insights. You are bridging the data. For what? The gaps which are given for data and action. Now this gap between data and action is something that you are oversimplifying the visuals. I have a visual. You just feel isko itna nahi chahiye. You don't need so much. So you simplify it in a normal way wherein the user will understand in a different way, where he cannot understand your perception of visualizing the picture. So he thinks something else and you think something else. This interpretation should not be there. So to fill the gap, this visualization technique is used. What is the gap? That it is bridging visualization between data and action. The second point is it is integral for decision making across various industries. Decision making across various industries. It encourages students to explore visualization tools and also create their projects. I hope the session is clear for you. Thank you.